Welcome to Black Adder Maths class. So we're going to do trig, 2-dimension trapezium. That's the shape. And what we need to look at is trapezium. We have BD is equals to BDC is equal to X. So we have BD is equals to DC. And we also have BD parallel to AC. So BDC, the angle there is 120 degrees. And then from there, we have to show that BC is root 3 x. So what you're going to do there, we're going to say that okay, so we have cosine rule. So that's the cosine rule that we need to apply. So the cosine rule would mean that we have D, which is BDC, and then there we have the known side, so we can use the cosine rule. So we have BC squared is equals to AC. We have also AC parallel to BC. AC parallel to BD. So we have BC squared is equals to X squared plus X squared again, the two sides, minus 2x multiplied by x cos 120 degrees. Then from there we have BC squared, which is 2x squared minus 2, we have x times x, so that is going to be x squared, and then we have cos that is going to be bracket. So we need to know that we have ABDC, all that sine, tan and cos. So we have cos 180 degrees minus 60 degrees. That is going to be cos 120 degrees. So which means cos 180 minus is going to be negative cos 60 degrees, and then we have the 60 degrees there angle, and we have 30 degrees, and then we have 2 as a hypotenuse, and then root 3 on the other side, and then that gives us cos 60 degrees gives us 1/2, so it's negative 1/2. So negative 1/2. So that will be equivalent to BC squared is equals to 2x squared plus negative next plus, and then we have 2x squared over 2. So the 2 cancels out, and then we have through 2x squared plus x squared, and that gives us BC is equals to plus or minus root 3x squared. So 2x squared plus x squared is 3x squared, so that's going to be root 3 multiplied by root x squared. So the squared cancels out, the power root 2 cancels out the power 2, so we have root 3x, which is equals to BC. So we have proven that part. The next question would be that we have BC given as 300 meters, and then we know that BC is equivalent to root 3x. We are required to solve for x, so we substitute BC with 300. So we have 300 is equals to root 3x. So that's gonna root 3x. So solving for x, divide both sides by root 3, so the root 3 cancels out. So we have x is equals to 300 over root 3. So we never leave root 3 on the bottom. So we're going to multiply both sides by root 3, then Okay, so the numerator and denominator multiplied by root 3. So the root 3 times the root 3 gives us the inner part, which is 3. So 300 divided by 3 is 100 root 3. So it's going to be 100 root 3. So 100 root 3, you can change that to decimal. It's equivalent to, you can punch that in a calculator. 100 times root 3 gives us 193.21 meter. So that is our answer, but I prefer without rounding off, which is 100 times root 3. That's the equivalent answer, appropriate one. So that side is parallel to that one, so those angles are the same because of equal distance BD and DC. So we need to know what are the angles on there. So going back, we can find out that just replicate the angle. We have x, and then we have x, we have 120 degrees, and then from there those sides are parallel, so alternative angles are equal. So which means we have to first find out what the values is. So interior angle adds up to 180. So we have a situation, we have 180 degrees minus 120 divided by 2, because of the two angles. So it's going to have 60 degrees divided by 2, and that means our angle is 30 degrees each. So it's 30 there and 30 degrees there. That in mind, what we do now is 30 degrees, and then that is going to be 30 degrees because they are parallel, BD parallel to AC. So now we have to resketch the triangle. So that will be triangle ABC. So from triangle ABC, we have 30 degrees there, and then we are told that BC is 300, so that is 300 there meter, and we also told that BC is 300, okay, that is noted, and then we also told that AB is 200, so AB is 200 meter, and then we need to find angle A, so we have to use sine rule. So using sine rule, we have sine 30 degrees. Okay, so it's a ratio, sine 30 degrees. Okay, let's use sine A over 300, and then we have sine 30 degrees over 200 meters. So cross multiplying there, we can see that we have 200 sine A is equals to 300 sine 30 degrees. So when we cross multiply, so it's 30 degrees sine multiplied by 300. So dividing both sides by 200, we find out that we have a value, so the 200 cancels out, so we have there angle A is equals to inverse function of sine bracket, we have inverse angle, we have sine 30 degrees multiplied by 300 meters, so multiply that by 300 all over 200. Okay, so finding that answer, our angle A is going to be equivalent to angle A is equivalent to, punching that in the calculator, we have 48.60 degrees. So that's our value for angle A. And then coming back on the last question, we are required to find the area. So we have two parts of we don't have the perpendicular angle parallel to the side, so what we have to do, we have to use area rule. So we have 48. That is it. Yeah, it's 48. Okay, let's resketch the shape here. So that is let's look at the shape as ABC. Okay, so we go back there and then we draw A, B, C, and then from there we have 30 degrees. There we have 48,6 degrees, and then there we have we find the remaining part that is going to be 180. Remember, the area of a triangle is 180 degrees, so it's going to be 180 degrees minus 48.6 minus 30 degrees to give us, punching that on the calculator, 180 minus 48.6 minus 30 gives us 101.4 degrees. So that's going to be 101.4 degrees. So with that information, we now use area. I mean, not area, we use area rule. So the area, okay, we have 200 meters there, and then we also have BC as 300. So fill in the information. There is going to be 300 meters. And therefore, area is half BC, half area. Area of triangle ABC, so that's going to be, what is it? So we find out using area rule. So we're going to use area rule. The reason is we don't have a perpendicular height known, so we're going to use the area rule. So it's going to be half, look at the two sides there, it's going to be half AC, then sine B. Yeah, half AC, then we have sine B, sine angle B. So it's gonna be half. Our A there is 300. Our A is 300 meters, and then our B is 200 meters, and then our sine B there, angle B, is 101.4 degrees. So we factor that as sine 101.4 degrees. So that gives us okay, just confirming the sides again. Okay, so that gives us 29408.4 meters squared. So that is our answer for triangle ABC. So we need to go and look at the other remaining triangle. So the other remaining triangle is going to be I think it's going to be BCD. So what informations we have for BCD? We have, checking on the previous answers that we had, our B there, BCD. Let's look again. We have X there is 100 root 3, so that's 100 root 3, and then the BC is also going to be the same since they're equal. It's 100 root 3 meter, that is 120 degrees, and then that one there is 30 degrees, and that one there is 30 degrees. So we need to find again using the area rule. So the area of triangle BCD here will give us half. Let's check the sides. It's B and D. So half BD sine C. Okay, BD sine C. So substituting, it's going to be a half B is 100 root 3. So that is going to be our B, and that is going to be our D. So let's know in the sides B and D, and our angle is C. Okay, from there that is B and D, and then we have our D as the same, 100 root 3 sine 20 degrees. Yeah, sine 120 degrees. And then that gives us punching that on the calculator gives us 7500 root 3. So that is equivalent to 129,904. That's gonna be equivalent to 129903.8 meters squared. Now to find the total trapezium, we add those two sides, the area of the two triangles. That will be area of triangle that would be triangle ABC plus triangle area of triangle BCD. So given values there, it's 29408.4 plus 129,903.8. So adding that with a calculator gives us 159,312.2 meters squared. So that's our final answer. I just want to thank everybody for watching. Please don't forget to subscribe or follow. Thank you.